So this will be the first lecture in Chemistry 1311, so General Chemistry 1 over Chapter 1. So in this course, so some of you have had AP Chemistry class, so you know General Chemistry pretty well already. And I would say this course is not much more difficult than an AP Chemistry class. But it's okay if you have absolutely no knowledge of chemistry whatsoever. I plan to cover every single thing that you need to know in this class, so with the understanding that you have no knowledge of chemistry to begin with at all. So everything that you need to know will be covered in these video lectures. So basically what I'm doing is I'm recording myself on an iPhone here. I have a iPad that I'm writing on with a software called Notability that's capturing what I write. And then at the end of this lecture, I'll save this in video and post it to D2L, post it to my YouTube channel, and then also send out the PDF file of the notes that I'm making here. And then I also have my typed out notes that I'll be emailing the class and posting to D2L as well. Okay, so again, we start at the very beginning with chemistry. This chapter 1 is pretty fundamental material. And if you've had a decent science class in high school before, you probably already know this material. But again, we'll just start at the very beginning, assuming that you know nothing about chemistry, and cover everything that you do need to know. Okay, so if we want to start talking about chemistry, then we need to talk about what is matter, do some basic definitions. So matter, basically all things are composed of something. What that something is what scientists call matter. So matter is anything then that occupies space. So it doesn't matter how big or how small it is. If it occupies space, it is matter. And of course in chemistry, we're generally talking about very small things. So classification of matter. So matter can be classified by its physical state and by its chemical composition. And I'll say more about that in a minute. And then if we want to subdivide matter, we could subdivide it into what's called substances and mixtures. And you can separate mixtures into pure substances by what's known as a physical process. And so I'll talk about physical processes, what that means in just a minute. Okay, so if you have a mixture then, mixtures can be subcategorized in terms of being a homogeneous mixture or heterogeneous. And in terms of a pure substance, we could break a substance down into what's called an element or a compound. Okay, so now let's go through what these terms mean. So first of all, for a physical state of matter, you could have what are the physical states of matter? Solid, liquid, and gas, of course. And there are other states of matter, such as a supercritical fluid that we'll talk about at some point in a future chapter. For now, we'll just keep it very basic: solid, liquids, and gases. Okay, so if you had a mixture, how could you separate a mixture into a pure substance? Through what's known as a physical process. And so some of these you're already familiar with. So how to separate matter using a physical process. So for example, if you wanted to separate a solid from a liquid, how would you do that? So you all probably have some experience with this, not necessarily in the chemistry lab, but maybe just at your home. If you've ever cooked spaghetti, for example, you have a solid and a liquid, right? You got the spaghetti noodles in the water. So when it's done cooking, how do you separate them? Well, you would basically pour them into colander, right? And separate the liquid or drain off. Basically, you're doing a filtration. So in chemistry, we would call this you would be doing a filtration. So you have to separate solids from liquids all the time in chemistry. So that's called a filtration. How would you separate two miscible liquids? So two miscible liquids, so that would be if you had alcohol and water mixed, for example. If you wanted to separate them, the process is called distillation. If you had two immiscible, well, so this is a term that maybe some of you don't know. What does miscible mean? That just means the two things are soluble in all proportions. So no matter how much of the two liquids you add to each other, you will never get two layers because they are soluble in all proportions. Okay, so what does it mean to have two immiscible liquids? So they would be easy to separate, right? So immiscible means they don't dissolve in each other. So if you have two immiscible liquids, they're easy to separate. So if you had this situation, gasoline and water don't mix. Which one's on top depends on density, right? The one that's more dense would be on the bottom, and the one that's less dense would be on top. And so those are easy to separate, right? You could just take a pipette and you could pipette out the top or the bottom layer. How would you separate two solids from each other? Well, you couldn't just take a piece of tweezers and separate the two different solids, right? Because molecules and compounds in chemistry are really, really tiny. So if you want to separate things like two solids, you need more elaborate separation techniques. So we'll just talk about a couple of them. One is called extraction. You could take the two solids and dissolve them into a liquid, for example, and maybe they have different solubilities. So maybe one, let's say, dissolves, call them compound A and compound B. Maybe A is water soluble, so it dissolves into a water layer, and maybe compound B does not dissolve in water and it dissolves in some organic solvent. So you take the two, dissolve them in these solvents, and use a piece of glassware that looks like this called a separatory funnel. And now you can drain the bottom layer out the bottom and then pour the top layer out the top. And now you've got the two compounds A and B separated. You would just need to evaporate the water and evaporate the organic solvent, and now you've got the two compounds separated. Or oftentimes in chemistry, what's done is what's called chromatography. And this is just a method to separate compounds based on their different affinities for a moving phase, typically a solvent or a gas, and a stationary phase. So we'll go through basics how this works. So you could do what's called TLC, that's an acronym for thin layer chromatography. So typically something like this, you would have an aluminum backing, and that would be coated with something like silicon dioxide, which is called silica gel. And then molecules have different affinities for silica gel. So as an example how this basically works, so you would take this TLC plate that's got this aluminum backing with silica gel coated on it, and you would draw a line with your pencil, and then you would take your mixture with a capillary and you would spot it, dab it onto that line, and then you would take that and put it into a beaker and cover the beaker and put some solvent in there. And then over time, what's going to happen is by capillary action, the solvent's going to go up the TLC plate and it's going to move compounds with it. So compounds are going to be absorbed onto the silica gel, and then they're going to dissolve into the solvent, and they're going to move up the plate. So they're constantly going back and forth between absorbed on the silicon dioxide and then dissolved in the solvent, and moving, absorb onto the silica gel, dissolve into the solvent, and move up the plate more. And so over time then, what you would find is you could separate this into different components. So we'll just say maybe whatever you dabbed, whatever the mixture was, maybe contains two things. So the one that moves the fastest has the least affinity for the silica gel, and the one that moves the slowest has the greatest affinity for the silica gel, so it doesn't spend as much time in the solvent, so it doesn't spend as much time moving up the plate. So then what you would do is you would scale this up to using a column. So you would pack the column with silicon dioxide, silica gel, and then you would take your mixture and you would put your mixture on top of the silica gel, and then over time, then the mixture is gonna, now it's by gravity action, it's gonna start moving down the column, and so as it moves down the column, then it's going to separate. Because the different compounds have different affinity for the silica gel. So some spend a lot of time attached to the silica gel and not much time in the solvent, so they're going to stay towards the top of the column and sometimes have a much greater solubility in the solvent, less affinity for the silica gel, so they would move down the column faster. And then eventually one of the components would start coming off the column, so you could isolate it, and the other component would be on the column still. And so now once all of the pink compound has come off the column, for example, you swap out the beakers, and then eventually the other component starts coming off the column. And now you've got the two components separated, and now you just have to remove the solvent. Okay, so that's basically how you would separate mixtures and substances: filtrations, extractions, chromatography, crystallization. Maybe you can get one compound to crystallize and not another, and then you could filter it off. Okay, so with regards to phase changes then, so some more terminology for you to know. So if you have a solid, liquid, and gas, what's the terms for change in between those phases? If you have a solid and it changes to liquid, so if you have an ice and it changes to water, what's that called? It's called melting, right? If you have a liquid and it evaporates into the gas phase, then that would be called evaporization or vaporization. Or if you go the opposite way, gas, and if it converts to liquid, that would be condensation. So that's something you're all familiar with, right? If you come outside in the morning after a humid day, then the humidity, as the air cools off, the air can hold less water vapor, so it'll condense out onto the window and onto the grass. Converting a liquid, so water into a block of ice, would be freezing. So these we're all familiar with. There's two other possibilities, right? You could go directly from the solid to the gas phase. So what is that called? So that's called sublimation, and you may be familiar with an example. Dry ice, right, is frozen CO2, frozen carbon dioxide. So you can buy this at Berkshire's. It is dangerous to handle because it's so cold. You could get frostbite if you handle it. But it'll go directly from the solid phase to the gas phase at atmospheric pressure without going through an intermediate liquid phase. So if you took a block of dry ice and set it on this table and came back 30 minutes later, so if you took a block of dry ice and water ice and put them on the table, came back 30 minutes later, and for the water ice, what you would see is, of course, a puddle of water because it's going to go from the liquid to the solid to the liquid state. And for the dry ice, you would see just the block of dry ice is smaller with no liquid phase around it because it's going directly from the liquid phase to the gas phase. And the other possibility, which is the least common and one that's least familiar to everyone, is gas to solid, and that's called deposition. So this is something that's used in the computer industry quite a bit to deposit things directly from the gas phase onto silicon wafers, for example. Okay, so a little bit more about the different phases of matter. So, how would you, if you were asked to define what is a solid, what is a liquid, what is a gas? Well, so if these round circles represent different molecules, for example, if it's a solid, then it has a defined shape, right? And it's not very compressible. Whereas if it's a liquid, then a liquid's going to adopt the shape of its container, and of course it's going to be pulled at the bottom of the container because of gravity. So liquids adopt the shape of its container, solids do not. And then liquids are not very compressible like solids. And then if you had a gas instead, so what would this look like if it was a gas? Well, gases also adopt the shape of their container. But in this case, they would occupy the entire container, and of course we have it capped. If it wasn't capped, then the gas molecules would escape into the atmosphere. So they also adopt the shape of their container. But unlike liquids, gases are very compressible. So if you could take that container and you could compress it into a smaller volume. Of course, that would just make the pressure of the gas go up, but you could compress the gas. Okay, so to finish this off, so what are the definitions of these other compounds? Of these other definitions of matter? So a substance is a kind of matter that cannot be converted into other kinds of matter by a physical process. And if we subdivide substance into elements and compounds, so what is an element? So it's that from which all things are made. So basically this is the elements, so this is the matter that's identified on the periodic table. So there are 118 different elements known. So in theory then, unless there are other elements in the universe that have simply not been discovered yet, every single thing in the universe is composed of some combination of any of these 118 elements that are known. So what is a compound? So a compound is a substance that cannot be separated into two or more. Well, it cannot be substituted. It cannot be decomposed into two or more elements by a physical process. It's composed of two or more elements chemically combined in fixed proportions. So those two or more elements, they don't have to be different elements. They can be the same elements. So H2, for example, is two hydrogen atoms bonded to each other. That's a compound. Or it can be different elements like water. So hydrogen is attached to oxygen. Or glucose is C6H12O6. So those would be compounds. Two or more elements chemically combined. And what does it mean in fixed proportions? That means water, for example, is always two hydrogens and one oxygen. If water on the moon or water on Mars and water on Earth is all H2O, two hydrogens and one oxygen, right? If glucose is found somewhere else in the universe, it will be C6H12O6. So that ties in with this law of constant composition. So a pure compound, doesn't matter where it comes from in the universe, it always will contain the same proportion of elements by mass. So 1 gram of sodium chloride, for example, is always, no matter where it comes from, 0.3934 grams of sodium and 0.6066 grams of chlorine. So of course we know what a mixture is. So what's the difference between a homogeneous and a heterogeneous mixture? So homogeneous mixture is one that is homogeneous throughout. So an example would be salt water. If you take a little bit of table salt and sprinkle it into water, it's going to dissolve, and of course it still looks like water. You can't tell that you've done anything because it's uniform. Let's not use the same term to define the word. So it's a mixture that's uniform throughout. Heterogeneous mixture would of course then be one that is not uniform throughout. So it consists of physically distinct parts. So it could be two immiscible liquids, for example, like we looked at earlier. That would be a heterogeneous mixture. Salt water can be made heterogeneous. So how could you make salt water heterogeneous? You could just keep adding a whole bunch of salt. At some point, the salt will stop dissolving, right? And then you would have an aqueous solution, and then you would have some sodium chloride that has not dissolved because the water can't dissolve that much, and so now you would have two physically distinct parts, right? You would have solid and liquid in this case. Okay, so then lastly, what does chemical change mean? So that would be, so you can convert elements and compounds between each other through a chemical process or a chemical reaction. So that would be a chemical change. So a chemical change is one in which two or more kinds of matter are transformed into new kinds of matter or several different kinds of matter. So that's an example. So this would be a chemical reaction. Hydrogen gas will react with oxygen gas to make H2O. So we've changed the way atoms are attached to each other. So initially, for example, hydrogens were attached to each other and oxygens were attached to each other. And now you've made water where hydrogens are attached to oxygens instead. So that would be a chemical change. And in this case, you would be changing one substance or one compound, in this case 2 different compounds, right? These are both compounds. And now you've made a new compound because you've changed the way atoms are attached to each other. Okay, so that's the basic definitions of matter and its subcategories.